Great, thank you. We kind of have a double presentation here. It involves something in the back room. Some of you might be eyeing it already. Bill Wetzel and Jyoti Saraswat.
I'm sure everyone's awake now, given that Kentucky bourbon is up on the slide. There is some bourbon in the back room, so please do help yourselves to that. Jyoti and I will be talking about Wes gets up right away. Somebody, yeah, we're serious. Please, go right ahead. As I'm all right. So, I guess thank you to the committee, the selection committee, for giving us this opportunity. I know both Jyoti and I and our students have really had a lot of fun kind of really working on this project. This is a project that, unlike Chris and Ray, who've been working on this for years or decades, this is really something that's new to both of us, and kind of introducing new ideas and new technology into our departments, and that's very exciting. So I'll talk a little bit about some of the chemistry and some of the things that kind of spurred this project, and then I'll pass it over to Jyoti here in a bit. So why are we interested in bourbon? Well, other than it's quite tasty, bourbon is one of the very important industries here in Kentucky. The Kentucky Distillers Association commissioned the study, and there were 52 distilleries here in about 2016, and that's up really threefold since 2009 because of the emergence of a lot of craft distilleries. And we're seeing those craft distilleries here in this area as well, so down in Newport and so on, and across the river in Ohio. The bourbon industry is responsible for a large number of jobs in the state, fairly large $8.5 billion economic output. So, it's an important industry for the state of Kentucky. Because of its importance, it's important that we ensure the integrity of bourbon, ensure the integrity of the products that are produced and sold. And so a lot of the distilleries are now kind of focusing on cracking down on counterfeit bourbons, all right? And so this was an article from Distillery Trail where Buffalo Trace spent a large amount of money cracking down on someone who was selling counterfeit Pappy Van Winkle bourbon on the market. And as that kind of picture there on the right of the slide illustrates, trying to identify a counterfeit isn't necessarily an easy thing to do. It's not something that you could visually look at and say, yeah, this isn't the true thing. And so how do we identify that counterfeit? How do we pick out what is unauthentic material? And especially when we think about bourbon, bourbon is a highly, highly complicated puzzle that we need to try to think about. So picture of some bourbon, different bourbon products on the left. These are a handful of the chemical compounds. It doesn't matter. All I want to kind of point out here is that there are a lot of different chemical compounds, and there are some that look very different, right, and some that look very, very similar, right? Especially the ones down here on the bottom of the slide. Notice that long chain just kind of keeps growing and growing and growing. And so trying to pick out these differences chemically often can be pretty challenging, all right? And so how do we go about doing that? And the cool thing is we've got equipment here on campus that has the ability to do this, has the ability to look at these bourbon samples a little more carefully. So what we do with this instrument, so this is a gas chromatography system coupled with a mass spectrometer. This instrument, this piece of equipment, allows us to essentially fingerprint a bourbon, all right? And there are a lot of different ways in which we can fingerprint that, and I'll show some fingerprints here in a little bit. But the important thing is that we can use this to not only determine what chemical compounds are present, but we can also identify how much of each one is present, all right? And so all we need is a very, very small amount of bourbon, all right? So 1 microliter. Now to give you kind of an illustration, this vial here contains 3 mils, all right? I need about 1/3000th of this vial to introduce into this system, and then we can get the information we need, all right? So if anyone wants to contribute to our project, I would gladly take the 2-liter bottle of whatever, and I'll save the 1 microliter and then we'll take care of the rest. So what we do with this system is we take that complicated mixture, we use gas chromatography to basically sort things out, and then once we have everything sorted, once we have all of those chemical compounds in different piles, then we can identify what they look like, all right? So here's what one of those fingerprints looks like, all right, for Eagle Rare. This is Eagle Rare 10 year, and the fingerprint for that bourbon looks like that chromatogram you see up top there. And so what we have is kind of the vertical axis is the intensity, how much. The higher it goes, the more we have. And then along the horizontal axis is time, but basically that's just different compounds are going to come out at different times, all right? And so we have different compounds of different intensities, and so that's our fingerprint for Eagle Rare 10 year. Now the cool thing is there's a lot more information going on here than what this plot shows. We can select one of those peaks, one of those chemical compounds that comes out, and we can, in our instrument, take that molecule and break it apart into pieces. And if we break that molecule apart into pieces, we get a pattern of those chunks. We weigh the different pieces, and we get a pattern that looks like what you see there on the bottom left-hand part of the slide. The really, really cool part is that every single chemical component, every single chemical compound has its own unique pattern. So here's ethyl caprolate, but if we look at 3 other peaks, right, going along with that first one, at different times, notice the pattern changes, right? And those patterns are incredibly reproducible, right? So these patterns tell us, give us a good indication of what chemical compound is present, so we can identify all of those different things that are there in that top fingerprint. Now, if we take something like a sample of Pappy, right, we get a fingerprint that you see up on the top. If we try Irish whiskey, we get a completely different fingerprint, right? If we go to, and I got this from my wife, I think this is back from our college days, peppermint schnapps, all right? Different fingerprint. And then if we go to really high quality Bud Light lime, some of our undergrads who were helping on this project, they provided that sample. So we have something that's completely different as well, all right? And so the really cool thing is just this fingerprint is going to allow us to kind of differentiate one type of alcohol from another. Now, another fascinating similarity is if we look at different kinds of bourbons, all right? And so these are all bourbon samples, Eagle Rare up on the top, Old Forester and Cooper Craft on the bottom. There are similarities here in these. Notice, I'm gonna get out my laser pointer here, but, yep, maybe not. All right, well anyway, notice there's a peak right around 9 minutes there. Thank you. There you go. See, the big one went out. Peak around 9, that's common to all of them. There's another one around 13, 12 or 13 that's common. Different intensities, but the pattern is similar, right? Subtle differences, but that fingerprint, that pattern is similar. Okay, so these are all bourbon. But the fascinating thing is, look how similar the bottom two are. Old Forester and Cooper's Craft are both Louisville bourbons. Well, when they make the bourbon, they take it out of the barrel, and then they have to cut that bourbon with water. The water source for those two Louisville-based bourbons is going to be the Louisville City water, and notice again the similarities there. So it's really kind of fascinating that you can see kind of those similarities in location even, all right? And that's something that we're going to be looking at further. So this really is a very, very complicated problem. Over the, kind of towards the end of the semester, then over the summer, we analyzed 155 alcohol samples, identified over 1,500 chemical compounds, 202 of those were unique, and generated a crazy amount of information. So just under 1 gigabyte of information. And trying to find the patterns in that data is incredibly difficult, incredibly difficult. And so that's where we need more sophisticated tools, more sophisticated ways to look at this immense amount of data, all right? And so I'm going to hand that over to Jyoti to talk about the next one.
All right, hello everybody. So here comes the statistics part, I guess. So you've been informed that it is a lot of data. Now the bigger question is how to make meaningful sense of that data. And that is why we'll look at the statistical analysis of Kentucky bourbon along with other alcoholic beverages. All right, so here's the data, at least a screenshot of it. So we use Excel, easy to manipulate Excel in the software which we're using. So the data which Bill collected over summer and the students which worked over the span of spring semester, we collected all the data, put out of the GCMS in an Excel file. And I mean, I can point out some of the samples which are listed over here, and these are the compounds along, and I think descending intensity and so on. So the software which we use to manipulate the Excel data is MATLAB. We have an academic license, and I want to take a moment to point that out, that our department has Mathematica as well as MATLAB. These two softwares are very popular in the science and engineering community. They're very user-friendly, and they can add it to your resume, so something to advertise to a student, and our students learn those things here. So in order to analyze the data statistically, I wrote a tiny piece of code, which is right over here. So this code, though it is tiny, it not only analyzes the data statistically, it runs a principal component analysis, and it also generates the graph which you see here. So it looks like all magic, but there is a lot of stuff which is going in the background. So as Bill pointed out, we have a lot of data. How do we visually see the differences and also the similarities between different samples, our different alcohols? Now the list which you see here, we have everything from beer, blended whiskey, to whiskey moonshine, flavored brandy, white wine, and well, I mean, every sample which we run, minus the replicates. If you notice, there are 106 alcohol samples, 155 had replicates. And we are thankful to the faculty who donated. You know who you are, and they're here, so that we didn't have to steal. And we also thankful to a random stranger who kindly donated a lot of samples to one of our student Amy Rice. So the main focus, and I'm showing you this graph, I was really worried that I didn't want to make those circles really big. All these circles which you see, they represent each kind of alcohol. I have labeled a few, and I'll talk about them in just a bit. So I'm going to zoom in on this part, because that is where the bourbon cluster is, all in red. Now, just for the sake of fun, I wanted to see, hey, how does bourbon and whiskey fare? So we're going to zoom in only on the bourbon and whiskey. I took out all the other alcohols. So this plot basically has not only bourbon, it also has blended whiskey, whiskey moonshine, white whiskey, rye whiskey, and all that. I'm going to be honest here, before moving to Kentucky, I had no idea that bourbon and whiskey were different. Don't judge me. But anyway, now I know. So if you notice, this is the bourbon cluster. The bourbon tends to show a pattern that is kind of close together if you zoom in on it. And some of the whiskey, especially the flavored whiskey, is showing up here. Now, interestingly, if you notice this name which I'm pointing my pointer at, Evan Williams Peach, which is sitting right there. It is supposed to be a Kentucky straight bourbon blended with peach liqueur, but it just decided to do its own thing. It's sitting right over there. We need further investigation. Is the peach responsible? And you guys are probably sipping it right now, so you might provide some feedback. All right, now this is the most exciting slide of our presentation. Bill talked to you about how to check for authenticity, counterfeiting, and so on. Now the question is, say your uncle left you a bottle of bourbon, it has no label on it, and you want to know if it is happy or not. Right. Or maybe somebody is claiming that, oh, I'm selling a really old bottle of a really good bourbon. How do you find out if it is authentic or if it is the same brand they're advertising? All right, bring it to us. Okay. So this graph basically, say suppose you bring me a vial of bourbon and you want to check if it is Eagle Rare or not. So because we ran the reproducibility for Eagle Rare, this little cluster here is like about 31 samples of the same Eagle Rare. So our principal component analysis, which we ran with an unknown sample, which are no longer unknown here, kind of tells you that the Pappy or the Willet or the Woodford Reserve, they are separate from that cluster. So by just looking, visualizing this graph, by visualizing the data, you can tell, okay, at least that whether the unknown sample is Eagle Rare or it is some other alcohol. So those kind of tests can be run, and it is a good way to know if the unknown alcohol is bourbon or beer or something else. All right, so what did we accomplish? Well, so the chemical fingerprint of each bourbon. And then, so the last slide, as I mentioned, it is good to assess the authenticity to eliminate counterfeits. It's a big thing. These distilleries are always trying to find newer ways or newer techniques to determine and to stop counterfeits. And it can also, so we've been talking to people, the other distilleries, and so on. How do you identify, are there any differences between different batches of bourbon, like 2016 versus 1998? Or even by the location of the barrel, the way bourbon is aged, the bottom level barrel versus the top level barrel, is there a difference? So those kind of things can be tracked and it can be of interest. All right, so future work.
So earlier in the summer, Kevin Reynolds had run into the owner of the OTR Stillhouse. This is a kind of startup distillery in over the Rhine area, and we started talking about possible collaborations. All right, and in those conversations, they had given us a sample of their white dog. So back in June, they first took kind of that initial alcohol from the process and placed that into the barrel to age. All right, and so they gave us a sample of that white dog that was placed into the barrel. We analyzed that using the GCMS and then placed that into principal component analysis. And then over the course of the next however many years, we are going to basically track the evolution of that bourbon and see how it evolves over time, how it moves on the principal component space, how the chromatogram that you see up top changes. Right? So that's really a very exciting opportunity, for us and for our students.
So like if you notice, I can't see that blue, so that is right there. So that's the white dog, and the rest of all is the bourbon cluster over here. So we did not know what to expect when we ran this analysis, but it looks like it's home. Oh, sorry. So we're still exploring certain possibilities of collaboration, and maybe Bill can say more about it.
So yeah, we are looking at other possible collaborations with other distilleries on the Bourbon Trail, or some of the new craft distilleries that are kind of cropping up as well. One of the other kind of exciting opportunities that we have, again with this grant, so we were able to purchase a chemical fiber, and the fiber is about the thickness of human hair. And that fiber is cool because it has a coating which will allow us to actually sample the vapors coming off of here. Right? And so we're actually going to do kind of a study looking at the aroma from the bourbons and see what kind of characteristics in terms of scent that those bourbons have. Right? And so that's kind of one of the many future goals that we have with this.
So this project is far from done. What you saw was the tip of the iceberg. We're really excited, me and the boat and our students and so on, because we look at it as a good experiential learning opportunity, and bourbon is always exciting. Right. So I just showed you one statistical analysis, that was principal component analysis, and then we like to run more data analysis, like cluster analysis and so on. And can I say I am a mathematician, I'm not a statistician, so this was way out of my comfort zone. hoping that we'll get there. We're working on it. So, well, thank you so much. And
Have some more bourbon.
So I have a question. With all of this diagram it's great. Is there any way to developing a quality scale as far as tasting goes?
So that's
You're identifying all of the elements for where these distillers want to be. Is that down the
That's
road?
a good question, a very good question. One of the things that we have tracked but haven't manipulated the data with, we've tracked the filler scores for some of the bourbons that we've looked at. And so ultimately, we want to kind of do a PCA plot looking at those scores and say, well, are the higher score ones in one region or another? So I don't know what we're going to find, but that is something that we've talked about.
so we can change the classifier in the analysis which we use. For this, we use intensities. We can change the classifiers and see how the data shows up on the plots. Yeah.
Is this the same equipment that they're using at the hospital?
It is in the same family.
Okay.
So at the hospital, so John and I
So a
went.
student trained on this could easily slide to the hospital medical lab?
Absolutely. Yeah, absolutely. Different front end, but identical back end.
It's far reaching.
Oh, you should. Maybe you should use
Hey, Bill, I have some wonder, do you know of any colleges or universities around here? I've heard of people offering majors in brewing beer because that's such a big industry now. I wonder if there's any institutions around here that are doing that, and this should maybe be a cool course or collaboration with anybody that's that type of major.
Midway's doing it.
What was that?
You said Midway is?
Midway. Okay.
So I don't know, I know that beer was different, but there may be a crossover with some institutions that offer that.
All right, thank you. And keep in mind, if you have bourbon, the mints on your table, take one of those before you drive.